So this is the second video which we're going to show you. Choose another point. Remember the previous video showed you point A. Now we're going to choose point B here. We're going to write the similar equations. Step number 2. We're going to choose B. For the part B, we have a VB. V0, we know this is must be V0, so that's what we have here, V0. And equals 4 pi epsilon 0. We also have 3 charges. So this time I'm only going to use these expressions, just directly write them down. Q1 A minus R plus Q2 R minus B. Remember my point B is over here now, so this is the point B. So that's what I have. And so the Q2 and the Q3, just be careful. Q3 is from here to there, so therefore the distance will be R minus C. In this case, my Q3, so in other words, these two terms adds up should be 0 again, because this is from Q1 and Q2. And this last term should be equals V0, right? This last term should be equals 0. In other words, Q3 R minus C 1 over epsilon 0. So 1 minus epsilon 0. So this term is going to equal V0. These two are 0. So the only term remaining is this one here. So now you see you have Q3 just equals 4 pi epsilon 0 V0 R minus C, like this. If you compare these two equations, one is over here, one over there, you see these two equations, you see the C has to be 0. This C has to be 0. From 1 and 2, we conclude C must be 0. So once the C is 0, and so then my Q3 will be 4 pi epsilon 0 V0 R. And I found out how large the, in this case, the results will be. So that's the Q. And this is the case that the entire calculation is independent on the how large the charge that is. So you see Q2, Q3 will be the stay same. So this is the case if my V0 is fixed at this point. So far, this is generic, and then our Q2, which we're looking for, and Q2 and B, these are all exact the same value as we discussed last time, in the sense that this Q2 just equals negative capital R divided by A and times Q. So this is what we have. Y my B here is just equals R squared over A. And this concludes the my second video of this particular problem. So we got Q3, we got this one.